You can store information persistently on an Android device in simple files. The files can either be text-based or binary. For the examples in this chapter, I'll focus on simple text since it'll be easier to see the results. But binary files work pretty much the same way as they do in any other Java-based platform. Android distinguishes between internal and external storage areas. Files saved to internal storage are hidden from the device user and are tightly associated with the app. When an app is uninstalled, any file in its internal storage area is deleted automatically. Many files that are created by parts of the Android SDK, such as SQL-like databases and shared preference files, are always created in this internal storage area, but you can create your own arbitrary files there as well. You don't need any special permissions to create and read internal storage files. You can just start coding in Java. I'll start this demo by declaring a string that will be the name of a file I want to create. I'll put it up here as a field of my main activity class. I'll start with PSF for private static final and press tab. I'll make this a string and I'll give it a constant name of file name. And I'll give it a value of loremipsum.txt. Note when working with internal storage files that you can't include directory separators. Files always go into the root directory of the internal storage area or wherever the application framework decides to put them. Next, I'll go to the event handler for a button that has the label of Create. Let's take a look at what this screen is going to look like. It'll be using this layout file, and it has buttons labeled Create, Read, and Delete at the bottom. First, I need some content to write to a file, and I've provided that in a string resource in the values directory, in strings.xml, and it has an ID of lorem ipsum. It's a paragraph of Latin text. So over here, I'll get that as a string. I'll create a string variable that I'll name string lowercase, and I'll call the getString method from the context, and then I'll pass in the ID of r.string.lorem ipsum. Next, I need a file output stream. This is a standard Java file output stream. It comes from java.io, and I'll name it File Output Stream. And for the moment, I'll set it as null. I'm going to have to wrap all of the code working directly with the file output stream in a try-catch block. And I'm going to have to close that stream eventually in a finally block. So I declare it first outside of all that so it's accessible to all those bits of code. Next, I need to declare a file object. And once again, this is a standard Java class from java.io, and I'll instantiate it with its constructor, passing in the name of the file I want to create. Now I'm ready to work with the file output stream. I'll instantiate the file output stream by calling a special Android method named openFileOutput. This takes two arguments, the name of the file you want to write to, and a mode. The name of the file will be my constant, file name, and the mode typically will either be mode private to create a new file or mode append to an existing file. I'll choose mode private. Notice the error indicator. I'll come back to that in a moment. Now I'm ready to write the file to storage. I'll call fileOutputStream.write. I'm looking for a byte array, and I'll get that from the string, passing in string.getBytes. And then I'll display a toast message and tell the user that the file was written to storage. Now I have error indicators both on the call to open file output and to the write method. I'll solve those by wrapping all this code in a try-catch block. I'll select those 3 lines of code and go to the menu and choose Code, Surround With. And I'll choose option number 8, Try-Catch Finally. And that wraps all the code exactly the way I want. Now, for this demonstration, if I get an exception, I want to see it immediately. So I'll add another toast message, and I'll display the word exception, and then I'll append e.getMessage. I'm going to add some line feeds in here to make it a little bit easier to read. And then in the finally block, I need to close that output stream. I'll call fileOutputStream.close, and I get another error indicator, and I'll solve that one by surrounding it with a try-catch block. Now, there are more elegant ways to do this sort of thing using libraries that have file utility tools, such as Apache Commons or Guava from Google. But this is how you do it in pure Java. You create the file output stream using the Open File Output method, you write to the stream, and then you close it, and you handle all the possible exceptions as needed. So now I'm ready to run the code and create the file. I'll click the Create button, and I see that the file has been written to storage. And to verify that, I'll go to the menu and I'll choose Tools, Android, and I'll open the Android Device Monitor again. And when it opens, I'll go to the File Explorer, and I'll go to the same area where I looked at my preferences files before, data/data. I'll scroll down and find my app's ID. That's com.example.android.data. I'll look under Files, and there's my lorem ipsum file. And you can pull the file down to your local computer and look at it in a text editor. It'll contain exactly the same text that I wrote to it. So the file has been stored persistently and will stay on the device as long as the app that created it hasn't been uninstalled or the user hasn't cleared local data storage. You can also place files in a cache directory. These can be automatically deleted by the app framework if it's low on storage space, and in a temp directory. Look at the various methods from the documentation that will show you other ways of addressing files. Now, if you've worked with files in Java on other platforms, you'll see that the techniques are pretty much the same here. You're using the java.io package, and the only thing that's really different is the use of the Open File Output method instead of creating a file output stream from scratch. But there's a limitation to be aware of. Android doesn't implement the newer NIO.2 interfaces that were introduced in Java 7, so you can't use the path class or other components of that newer library at this point. But you also have some file management tools that are unique to Android. For example, the context class, which is the superclass of activity and service, has methods named delete and delete file, which automatically operate on files in internal storage. So now I'll add some code to delete that file. I'll go down here to the onDelete button click method, and I'll create a file. And this time I'll pass in a path name, starting with getFilesDir. And then I'll pass in the file name. Then I'll add an if condition, and I'll ask whether the file exists. With if file.exists, and if so, I'll call the method deleteFile. Now, when I call deleteFile, I just pass in the file name. I don't pass in the entire file location. And if I successfully deleted the file, I'll do a toast message saying file deleted, and otherwise I'll display a toast message saying that the file didn't exist. And I'll run the app one more time. When the app relaunches, I'll click the delete button, and I see the message that the file was deleted. And if I click the button a second time, then I'll see the message that the file doesn't exist. Now again, files created in internal storage are only available to the app that created them. To create files that can be shared between apps and can be seen by device users, put them in external storage. And I'll describe that technique in the next video.